resources for your EC2 instances, for all your compute resources to stay within one network. Okay, so and we also looked at what a network boundaries would look like, right? And this red box that I drew, and then the red box is a logical extension. VPC red box is a logical extension of your private office network, okay, which has got its own subnets, okay, and then I also looked at the various different boundaries that you have the dotted lines, which is your AWS account. Then you have the red box, which is the virtual private cloud, which you create. How do you create virtual private cloud? You give a name to it and you give a CIDR range to it, CIDR IP address range to it. What is the CIDR IP address range? CIDR IP address range is a notation with which you specify what should be the range of the IP address that your VPC should contain. So it has /8, /12, /16, /24, /28. But what does VPC support? VPC supports a maximum of /16 and a minimum of /28. Okay, and you select a region where you want to create a VPC in, and within VPC, this black box that you see is basically the availability zone, where North Mumbai is one availability zone, South Mumbai is another availability zone, probably split with a distance of about 100 kilometers for high availability to protect itself from any natural disasters or any other local availability zone related failures. So, and within that you create a subnet. A subnet is mapped to an availability zone, and the subnet will have a name, and subnet will have a CIDR IP address range associated with it. The IP address range of subnet has to be a subset of your VPC's CIDR range, and no two CIDR range and subnets can overlap with each other. Each has to be unique. Each range has to be unique. Okay, so this is what we looked at yesterday. Just a quick recap. Provides control of IP addressing using CIDR block from a minimum of /28 to a maximum of /16. Supports IPv4 and IPv6 addressing. VPC spans all the availability zones of a region. So when you create a VPC in your account in one region, you can use that VPC in any availability zone because it's a logical entity. Okay, it's a virtual entity, right? So it can be spanned across any availability zone. VPC can contain one or more subnets in each availability zone. Okay, when you create a subnet, you specify the CIDR block of the subnet, which is a subset of the VPC CIDR block. Each subnet must reside entirely within one availability zone and cannot span zones. Okay, a subnet is within an availability zone, right? You can't have a subnet created like this. It doesn't support. It doesn't work that way. A subnet has to be within the one availability zone. So now look at it this way, right? I mean, we used to play that game in our childhood, right? Where we take a big box and find one more smaller box and put that small box inside that big box, and find one more small box and put it inside that other smaller box. Take one more small box, put it inside the other smaller box, and finally have the gift wrapped inside the smallest box, and then give that big box to somebody just for the sake of fun. And then somebody would open it, keep opening it, and then finally they'll find the gift inside that, right? So it's like this, right? So you have the VPC, which is the larger most box. Then you have the availability zone, which is the next entity. So then you have the subnet, which is the third entity. So look at it this way. Within VPC, you have availability zones. Within availability zone, you have subnets. Okay. And availability zones are distinct locations that are engineered to be isolated from failures in other availability zones. So that way, I gave an example where if North Mumbai data center, North Mumbai availability zone fails, South Mumbai is still there, right? People connecting in India can still be able to connect to South Mumbai, provided they have a high availability setup in the second availability zone. Of course, if they don't have a high availability and then they keep all their virtual machines, all their resources only in one availability zone, so then obviously they will have an outage. And by launching instances in separate availability zone, you can protect your applications from the failure of a single location. So again, the catch here is you have to launch it in separate availability zones and build your application for high availability. So then it works that way, right? So if you see here, yes, this is the region, the topmost is the region. Then the second box is your VPC, and the third box is your availability zone. Within availability zone, you will have your subnets. Okay, so that's the way a VPC works. Okay, so now today, what we are going to learn is we're going to learn two important topics. I would say out of these two important topics, route tables are the most important topic. Okay, we will spend most of our time today in learning route tables. Internet gateways, I'll tell you what internet gateways. Of course, it's a very simple concept, but route tables is the most important topic. Please pay attention. If you don't understand the route tables properly, then you won't be able to actually configure anything in the VPC. You won't be able to configure the right routing in the VPC, and you'll end up troubleshooting day in, day out, and your overall environment and setup will not work fine. Okay, so that's why route tables are very, very important, right? I gave an example yesterday. If you want to go from Kukatpalli to Secunderabad station, right? What is the route that you take? If you take a wrong route, you will not reach the Secunderabad station. You will reach elsewhere. Probably you will reach Lingampalli station. Instead of taking a left, if you take a right in Kukatpalli, right? And then you go straight towards Miapur, then you will only reach Lingampalli station. I doubt even you will be able to reach Lingampalli station, because you will get lost in the middle, right? So that's why routing is very, very, very important. You need to understand the concepts of how routing works. I mean, see, gone are the days where there were network engineers and network specialists, who used to configure the routes, and they had all sorts of jazzy certifications with them, Cisco, CCNA, okay, and a lot more jazzy designations and jazzy certifications and so on and so forth. But gone are the days. Right now, anybody, even without any knowledge of networking or with very limited knowledge of networking, will be able to configure routing using simple user interface. Okay, you don't need sophisticated things to do configure routing, right? So that's the whole beauty of cloud, right? So where in cloud you can understand the underlying infrastructure concepts, you can understand how applications work, you can understand how you can expose your applications to the external world, right? You get a hands-on with all of these concepts, right? You really don't have to understand how a route table how a routing works in a Cisco router or a Juniper firewall or whatever it is, right? So that's the simplicity and that's the abstraction that a cloud platform basically brings onto the table. Okay, so I'll go to the route tables. Okay, I'll just explain you what a route table is. Okay, what is a route table? Let me just zoom this in a bit. Yeah, what is a route table? I'm again referring back to the documentation, because I believe this is the best place where you can get up-to-date information about the various different services of AWS. Go to the AWS documentation, VPC user guide. This is where you find all of the information. You don't have to go searching for other websites, other things and things like that, right? I mean, you find everything here, right? I mean, you also get good examples, and you get so much of wealth of information is available on this documentation, right? So I would strongly recommend all of you to bookmark these that I sent yesterday, that I gave yesterday, right? And then you'll have to basically use those to you use those to basically ensure that you get all the information out of it. Sorry, just give me a second. Okay, all right. So what is a route table? Okay, so how many students have joined? Okay, about 70 odd students, right? Okay, so usually, sorry for taking a little pause here. So probably a question to Sai Krishna, Ravi, and mentors. So usually around this time, people would have joined, right? Most of them would have joined, correct?
Right.
Because I just want to ensure that I start these route tables. I want to ensure that people who have been attending the classes regularly are there, and right, so people who are there in the class, please put off everything, right, and don't do all tabs in your laptops and stuff. Don't look at other things. Please pay attention to this for the next 45 minutes to 1 hour. It's going to be extremely important. Okay. Okay. So what is route table, right? As I said, a route is basically a directions, right? It tells you, like, from here, I want to go from Pragati Nagar to Secunderabad. Then Google Maps tells me the directions, right? That, you cross the lake, Pragati Nagar Lake, go to JNTU, take a left from JNTU, keep going straight. At some point, you will get a detour, take a left from there, go straight. You can either go through Balanagar or you can go through Secunderabad, you can go through Sanat Nagar, right? Something like that, right? It's basically a set of rules, right? So set of rules is the most important thing that you'll have to understand. What is route table? Route table is a set of rules which has got the routes from Pragati Nagar to go to JNTU. That is a rule. So take this road, go to JNTU. From JNTU, take a left and go till Kukatpalli Y junction. Right? That's a rule. So it's basically a set of rules called routes that are used to determine where network traffic from your subnet or gateway is directed. Okay. Yeah. So that's where, you have your traffic which is going from one place to another place, or one source to another destination, is actually being redirected, or it is basically diverted or directed, I would say. Okay. It's very simple. Don't get too overwhelmed with this. Once you do some lab exercises, you should be able to get more understanding of it, right? So these are all the key concepts for route tables. So there's always a main route table. When you create a VPC, by default, the VPC comes with a primary route table, main route table, okay, which directs the traffic originating for the VPC from within the VPC to the VPC itself, right? So that way, any traffic that originates, it basically knows that within this, there is the traffic has to be routed. Okay, this comes along automatically, comes with your VPC. It controls the routing for all subnets that are not explicitly associated with any other route table. Okay, don't worry about that. I'll come to that. Then there's something called custom route table, where you have a route table that you create for. You can also create your own custom routes, right? Say you want to have a route table that says that, okay, instead of taking this path, take a different path. Okay, instead of going through by default going through this, route the traffic through a firewall. Like, for example, right, when in usual days, when we go from JNTU to Secunderabad, I take the route of Balanagar. Okay, but on a specific given day, I'm actually going, and suddenly I see that the left turn from Kukatpalli Y junction is blocked because there is there's some road work that is happening, or there is some sort of a priority which is given to that path, where probably a CM's convoy is actually passing through it. So they have blocked that route. So any traffic that originates from like JNTU, and which has to go to the destination of Secunderabad, has to go through Amirpet, Sanat Nagar, and then eventually go through Begumpet and then reach Secunderabad. Okay, so that's an exception where police has stopped it. So it's a custom. Okay, it's not the default. The default route is through Balanagar, but the custom route is through a different this thing, right? So here also, if you see a route table that you create for your VPC, where you can define your own rules. Okay, forget about edge association. I'll come to that later. Route table association is when you create a route table, and when you have so many subnets, right? A subnet is basically within the VPC, within an availability zone, right? Where it's a subset of the VPC, correct? So the subnet, you can basically associate a subnet to the route table, right? Unless you associate the subnet to the route table, any traffic originating from the subnet will not know where to go. Okay, it will be as good as blank. It doesn't know where to go. Like, for example, I'm going to a new city, okay, and I have GPS with me. I have a mobile phone which has got GPS with me, and I'm relying on Google Maps. Okay, suddenly somebody grabs the phone from me, or I lose the phone. or the phone stops working. I'm like left wondering, which direction should I take? I don't know whether to take left or right, go straight, and I don't know the language, and I don't know how to speak, of how to communicate to the people there. So I don't know. I'm like left stranded there, right? So that is the same situation that will happen to the subnet, right? So where you have a subnet, you have a route table associated with the subnet, then subnet will know the traffic coming from the subnet or destined for the subnet, it knows where to route the traffic. If you remove the route table from the subnet, it doesn't know where to go. Okay, and then I'll come to this internet gateway a bit later. And yeah, destination, right? Okay, forget about local gateway route table. I'll come to that later. Destination, right? So now, okay, so any rules that you specify in the route table, they are all destination based. They are not source based. Please understand that very clearly. They're all destination based. Okay, like for example, I am right now I'm using my Google Maps and I have my GPS enabled and I have my location enabled, right? So I want to go from here to Secunderabad, correct? What I'll do, I'll leave the source empty, right? Because source will take the current location from the current location, my location, but I'll give the destination. I'll give the destination as Secunderabad. I'll explicitly type on my screen saying that Secunderabad. So then what it does is it gives me the route, correct? Similarly, here also, any rule that you specify in the route table, they're all destination based. If for destination A, take this route. If for destination B, take this route. If for destination C, take this route. And how do you specify the destination? The destination has to be a CIDR notation. Okay, it can be a CIDR notation. It has to be a CIDR notation only. Okay, like in this case, an external corporate network with 172.16.00 CIDR, right? If you want to route the traffic from your AWS to your network, you have to say that routed to so-and-so path. So routed to so-and-so CIDR range. Okay, then propagation, right? What is propagation, right? Route propagation allows a virtual private gateway to automatically propagate routes to the route tables. Okay, propagation will come later because that touches the VPN. I'm not touching the VPN right now. I want all of you to understand the basics of route tables. Okay, and target. A target is the gateway, network interface, or connection through which to send the destination traffic. For example, an internet gateway. Okay, so now you have destination, right? You know the destination. Destination is nothing but where you want to reach, where you want the network packet to reach. But target is, imagine like this, right? I will just do a small whiteboarding for you guys. JNTU. Secunderabad. Okay. So now what you have is, this is the source and this is the destination. And these are all the intermediate stops. Okay. These are all the intermediate stops from JNTU. I go to Kukatpalli. Okay. From Kukatpalli, I go to first KPHP, then Kukatpalli, then Kukatpalli to Balanagar, then Balanagar to so this is basically route 1. Okay. where in the case of route 1, you have Balanagar, Boinpalli, Radband, and finally this route takes you to Secunderabad. Okay, this is one way of routing it, right? Routing the traffic from JNTU to Secunderabad. There's also another alternate route which could be potentially possible. Is you still have this Amirpet, Begumpet. This is also possible. Okay, so you have this as route 1. This is route 2. This is route 2. Okay, so now you have the individual routes, route 1, route 2. You can take either of the routes, correct? So now this is your destination. In like if I were to equate it with this, destination here is, what is the destination? The range of IP addresses where you want traffic to go, which is the destination CIDR. This could be a CIDR, destination CIDR, where this is your destination CIDR range, which is destination. Okay, this is your destination. This is your source. Of course, you are here. Okay, but what is target? Okay, the target is the gateway, network interface, or connection through which to send the destination traffic. Okay, so now these are targets, either route 1 or route 2. They are called the targets. I mean, the route with which you take it, right? Which route should it go? This is called the target. This is a target. Okay, so just understand this very clearly. Every time we say destination, that's the target, the final destination. Target is which route you have to take. That is the target, right? In this case, route 1 can be a okay. This can be slightly different also. Now, for example, route 1, I'm actually taking a RTC bus. Okay, that is the route that I'm taking. I mean, when I use RTC bus, it takes route 1. Whereas when I take metro, it takes the route 2. Okay, so that way, you're even in the case of VPC routing, a route can either be a VPN connection, or a route can be anything else, right? Route can be a different thing, where it has to go over internet. Probably it can go over internet, or it doesn't have to go over internet. It can be a VPN connection. It can be a VPN connection. Okay, that's basically the concept here. So understand it very clearly. Target is the path that it takes. Destination is the final destination where it has to land. Okay, final destination, which is the CIDR range where it has to land. Whereas target is basically the path, with which path that it has to take, whether it has to take a internet gateway, or it has to take a VPN connection, or it has to be a local path. That can also be possible, right? Within VPC, I don't want my traffic to go anywhere outside VPC. I want to talk from one subnet to another subnet. It has to talk within the VPC. It can just talk within the VPC, where it'll take the packet, it'll throw it back to the VPC. It'll go to the respective subnet. Subnet will send it to the target or the destination. Okay. So what target means is it is the gateway or the network interface or connection through which to send the destination traffic. Okay, and a local route is a default route communication within the VPC, right? So where, okay, in this case, say I'm actually in the vicinity of Secunderabad area itself, right? So basically what I can do is I can simply use the local route to communicate with the, to basically travel to one place to another place. Okay, so that's called a local route. You'll understand that better when I start doing the. Okay, so how route tables work? Okay, let me just, before that, I'll show you some examples of routing options. Yeah, see, when you create a route table, you have to take care of two entities, as I said, right? One destination, other target. Which route you have to take and what is the destination where you want to go. So these are the two things. You will see a table there when you configure it. You will see that. So destination will be a CIDR range and target will be what should be the target for this destination, which target it has to take. Okay. So you'll always see this destination target. So you should be very clear on what is the destination, what is the target that destination will be reached through. These are all few examples of it. Anyway, some of these you will understand it better when you get to do some actual real work. Yeah, okay, so if you see here, yeah, so VPC has got 3 route tables, route table A, B, and C. You have a destination and target. Any traffic originating for 10.0.0.16 will be local, whereas any traffic originating for 10.0.1/24. So the way it works is, if you see 10.0.1.0/24 is basically a subset of this, correct? Which is larger, 16 or 24?
16.
16 is larger, right? And moreover, you see 10.0.0.0. Okay, so now one more thing I kind of missed in yesterday's class is that you have the IP address notation, right? 0.0.0.0/0. This is the IP address CIDR notation, right? If all of you have read it. So now let's take an example of, I gave an example of 10.0.0.0/16, which is the maximum that a VPC can support, which can 65.536 IP addresses, correct? It can support a maximum of 65,536 IP addresses. Okay, so now what are these zeros mean actually? When you give a notation like this, what does the zero mean? When you give a CIDR notation, if you have an individual thing, individual IP address like 10.0.1.1, then it's fine, or 192.168.1.1, then it's fine, okay? But what does the zero mean here? Zero means in a CIDR notation, right? In a CIDR notation, what 0 means is 0 is basically the it's a variable out here. Okay, so now it can, the range of 10.0.0.16 can be from open cider.xyz .0.0.16 ranges from, first IP will be 10.0.0.1, last usable IP is 10.0.255.254. Okay, so now if you see your first octet is 10, which is common. Second octet is also 0, which is common. So first two octets are unchanged, but if you see third and fourth octet are changing, and they are the ones which are variable. So it starts from 10.0.0.1, 10.0.0.2, 10.0.0.3, and then it goes till 254. Then it starts with 10.0.1.0, 10.0.1, sorry, 10.0.1.1, then 10.0.1.2. Like that, it will go till 10.0.1.254. So like that, it'll keep incrementing the third octet and fourth octet, and in a multiple permutations combinations. Okay, that's how it is able to arrive at 65,536 IP addresses in this case. Okay, so you have to understand that very well. And what it actually means is that it's basically a variable here in this case, based on the subnet mask. Either the second octet or third octet or fourth octet is basically a variable. Okay, so now let's say 0.0.0.0. Yeah, see it gives you all the IPs in the world. 0.0.0.0/0 basically tells you how many ones, tens, 100,000, 10,000, lakhs, 10 lakhs, crores, 10 crores, 100 crores. So 400 crore IP addresses, right? Which is basically 400 crores is 40 billion, correct? Or 4 billion? Yeah, 4 billion. There are a total of 4 billion public IPs, right? I showed you the other day. Public IPv4 addresses are total 4 billion in the world. Okay, it tells you all the IP addresses. Now, if you build a data center which spans thousands of acres, and you want to basically put so many systems there, and you want to basically fill this entire space, you can also fill this entire space in your private network also. But of course, for private network, you have to go with the standardization of RFC 1918, which talks about only those 3 IP address ranges. But yeah, you can potentially do that. But if you see here, 0.0.0.0/0 means all, everything. It's like star, right? You have wildcard. When you say select star from table, what does it mean? You're not putting any condition there. You're just going by select star from table. What it does a full scan of the table. Okay, and then it gets all the rows, all the columns, every single bit of data it gets from the table. Correct? So that's basically the sorry, I'll have to just step into another thing. Just give me 2 minutes. I'm just putting you on mute. I'm sorry about that.
Yeah, we will continue.
Cool. Okay, sure. Sounds good. So let me share my screen again. Yeah. So now what I was trying to say is that whenever you say 0.0.0.0/0, it means that it is that the destination can be anything. Okay, the destination can be anything. If you have anything, if you have a specific, for example, if you want to route the traffic specifically to, let's assume, if you want to route the traffic specifically to 10.0.1.0/24, which has like about 256 IP addresses, right? So the range is 10.0.1.1 to 10.0.1.254. So if you say that your destination is 10.0.1.0/24, then it could be any IP address from this range. Okay, it could be a specific IP address from this range. It knows that in general, if I have to go to Secunderabad, I have to basically take this route. Okay, but once I reach clock tower, right, and once I reach kind of clock tower, and once I reach that the Secunderabad bus stand, from there I want to know where is the station, right? So then you need a specific thing, direction to say, a direction board that says, okay, here is the direction to station. Then you enter the station, Secunderabad railway station. From there, you have to specifically go to a platform number 5. So in order to go to platform number 2, because that's where your train is probably waiting for you. Okay, then you again find a board saying that go to platform number 5. Then you go to platform number 5, and then you actually get into the train and you find your place and you sit in your place. That is the actual IP address. The place where you're sitting is the actual IP address, right? For example, like coach S325 is your seat number, right? So now S325 is your actual IP address in the world of networks. But in general, if you have to go reach that place, all that you see is basically the directions. One thing leads to other, the other thing leads to other, the other thing leads to other, and then it keeps going on and on till you reach your destination, right? So from that perspective, if you give the destination as 10.0.1.0/24, then any IP address, any packet, any network packet which has the destination of any of these 256 IP addresses will actually go to this route, will follow this route, and it will follow that target. Okay, so that's why it's important you guys understand. See here, if you see my last octet is 0, correct? And my subnet mask is 24. Okay, so now /24 gives you 256. Okay, if you look at the the exponential formula that I pointed you all yesterday, right? 2 to the power 6 to 2 to the power 8. So the last octet is basically 0. Okay, it doesn't mean that it is 0. It means that this octet keeps changing based on this. In this case, the first IP address for this would be 10.0.1.1. Second IP address would be 10.0.1.2, 10.0.1.3. And then for whatever is the octet, it will go on till that point, right? It will go on till 254. I can also make this like 26. 26 will give me only 64 IP addresses. If I make it 28, it will give me only 16 IP addresses. If I make it 29, it gives me 8 IP addresses. If I make it 30, it gives me 4 IP addresses. If I make it 31, it gives me 2 IP addresses. If we make it 32, it gives me only 1 IP addresses. So if you want to specify only 1 IP address, that the destination is only so-and-so IP address, then you have to always mention /32. Okay, you have to mention /32, which is just 1 IP address, which is a very specific destination, nothing else. It's just very specific destination, because the way it works in the routers is a router will take this packet. Okay, the TCP packet. Okay, how many of you know the structure of a TCP packet? Can somebody explain what is the structure of a TCP packet? What all a TCP packet contains? Computer science students, you would have come across this in your
hello
colleges. Yes.
So source address, destination address, and packet address.
And packet?
Packet address, data address.
Okay, the actual packet itself.
Yeah.
Correct, the actual data itself, right? And it has got headers. TCP has got some headers. Okay, so now you can go through those headers. I'll point you to some of those. You can say TCP packet format. Okay, this is basically the packet format. Okay, so now you can basically go through this. It will tell you, what all fields that your TCP packet will have. Okay, and what your, as I don't know who was that, as he said, it is basically, it will have the source address, destination address. If you see here, I'll zoom this in a bit. Yeah, so if you see source address, destination address, then you have the data, which is actual data. Then you have some checksums, protocols, time to live. There's so many other things that are there. You don't have to worry about the other things, but the main thing is the source address and destination address, right? So those are the two key things that are there in a TCP packet. Okay, so from that perspective, what actually happens is when you send this to packet to the router will take this source destination address, and then the router will have a route where to send it as a next hop, right? Again, those are called hops in the network world, right? Where the first hop is KPHB, the next hop is Kukatpalli, next hop is Balanagar, then Bovenpalli, then Tadband, then finally Secunderabad. So each one is a hop, right? So where there is a router present in each hop, which knows for that destination what should be the next target. Then it puts it to the next target. Then it goes to the next hop. Then that has a route table which says, okay, for that destination, what should be the next target? The next target is Balanagar. Balanagar has a router which says for that it has to go to Bovenpalli. For that it has to go to Dhadband, and finally it will reach Secunderabad, right? So from that perspective, if you see, when the router receives it, it will send it to the next target, and then the target will take it. It will look up its own route table, and then it will say, okay, the next target should be this, and then it will push the packet to the next target. So that's how it finally reaches the 10.0.11/32. Okay, so now let's go back to route tables. Okay, so if you see, anytime you see 0000 is basically the destination for the route 00, which represents all IPv4 addresses. All, I mean, it is not specific, right? It's all, it can be anything at the end of the day, right? That is where, so the way it evaluates the routes in the route table is, there can be many rules in the route table. So what it does is it evaluates the more specific route first. Okay, it first evaluates the more specific route. If it doesn't find a more specific route, then it goes to the generic route, which has got a prefix, and then it basically uses that to send the packet to that particular target, right? Again, let me give an example of here. Now I'm saying that my more specific route is route 2 only. Okay, that is the more specific route. Now, for some reason, I'm not specifying the more specific route. Then it basically takes it to the default route, which says, okay, so now take it through KPHB, Kukatpalli, Balanagar, Bovenpalli, Tadband, and then Secunderabad. Okay, so that's how it basically works, and that's the reason why you need to understand what 000 means. 000 means two things: all the IP addresses. It can be anywhere. Okay, like for example, from my EC2 instance, say I want to talk to another EC2 instance within the same VPC. Okay, so now what I would do is I would give a more specific route within the VPC itself, which says use this route table and use this subnet for routing the traffic within the VPC. There is a more specific route. Okay, so now when you don't have a more specific route, when say for example your EC2 instance, you want to talk to Google. In order to talk to Google, you don't know what Google's IP address means, correct? It can be anything because it keeps changing, correct? So now in that case, you have to specify 0000, and then it has to go to an internet gateway. Internet gateway is nothing but, I explained you the other day, it is basically a ISP where you have router or modem. But in the case of VPC, internet gateway is attached to your VPC, and then you can use it to talk to internet. Your EC2 instance will be able to talk to internet through internet gateway. That is, as the name says, internet gateway. So you have to basically push that packet to internet gateway so that you'll be able to talk to Google and come back. Okay. So now that is why it's important that you understand what a destination and target means and what are the notations of 000, which means that any IP address for which I don't have a specific route mentioned, it can be any IP address, push it to internet gateway, let internet gateway, so that way any communication within okay, I'll give you one more example for you to easily understand this, right? So I've got a phone line at home, okay, and I have created a what is that called, an intercom. Okay, I don't know, these days intercom is quite okay. If you actually have gone to offices, correct, you have various desks and each desk has got a phone. Okay, so now I have an extension number called 123. Okay, and probably someone else might have, Sai Krishna will have a extension number 789. Okay, and when I want to talk to Sai Krishna, what I will do, I'll lift the phone, I'll directly dial the extension saying 789. It will ring on his phone, and then he'll be able to answer the phone and talk. But he's just sitting next the next desk. Okay, but what it does is it goes through the phone lines, the inter-office phone lines. It's called intercom. It goes through the intercom and then it routes the traffic to Sai Krishna's phone 789, and then he is able to answer it. Okay, so now if I were to make an external phone call, I want to say call my home, or I want to call someone else, my customer, which is a external phone line, right? What I will do, I will press 0. Once I press 0, then I press the mobile number of my customer, then I'm able to get connected to the customer and talk to the customer. Correct? So now this is exactly the way it works. Within the office, which is within the VPC, if I have to talk to Sai Krishna, I just press 789 and I'm able to talk to him. So within the VPC, if one IP address has to talk to another IP address, that flow will be within the VPC, which will take the local route. It won't go outside. It will take the local route, which is there in the route table, which is called as local. Whereas if I want to talk to any external number, then I press 0 and then it takes me to the external world, correct? Similarly, anything other than local, which is external, will follow the route of 0000/0, which will take an internet gateway in this case, which will go to the external network. It will get connected to Airtel, Vodafone, or Jio, or whatever it is, and then it will I'll be able to talk to the other person. Okay. CIDR blocks of IPv4 and v6 are treated separately. For example, a route with a destination of CIDR 000 does not automatically include all IPv6 addresses because the notation for IPv6 is different. Okay, so if any of you have got IPv6 in your home network, you will be able to see that. I'll show you an example. Okay, in fact, I think I have it. Okay, so if you see here, this is my IPv4 address of my laptop, which is connected to my local network, correct? My home network, 192.168.29.6. But at the same time, I also have a IPv6 address. This is the IPv6 address that I have. Okay, so the notation is very different. You see dots here, whereas in IPv6 you see 2 colons between each hexadecimal. Each is a hex. Actually, it's represented as hexadecimal. Okay, so now that's why if you see 0000 is basically all IP addresses, which is not specifically mentioned. Whereas in case of IPv6, you have to give :/0. This is for all IPv6 addresses. Okay, every route table contains a local route for communication within the VPC, like the example that I gave. Every office which has got a local intercom facility. So similarly, every route table contains a local route for communication within the office or within the VPC. This route is added by default to all route tables. If your VPC has more than one IPv4 CIDR blocks, route tables contain a local route for each IPv4 CIDR blocks, right? I can also add up to 5 CIDR blocks in my VPC, 5 non-overlapping CIDR blocks in my VPC. One can be 10.0.1/0/24. The other one can be 10.0.1/0.2/0/24. So like that, I can have 5 unique IP address ranges, which is non-overlapping in nature. They should not overlap with each other. And you will have a route table associated with each CIDR range that you have in your VPC. Okay, these are some of the examples, right? So where I have a route table which has destination and target associated to a VPC. So the first entry says any traffic that has a destination which belongs to this range. So 10.0.0.0/16 will have how many IP addresses? 65,536 IP addresses. Yes. So all of those will go locally within the VPC itself. It won't go outside. Okay. I have an office which has got 65,536 seats and 65,536 local phones, intercoms. So if I make a call from phone number 10 to phone number 256, extension number 10 to 256, it will be within the office itself. It won't go outside. Okay. Similarly, you also have a IPv6. You can ignore IPv6 for now. You don't, it will be confusing. Leave it. Okay. But I have a range of some different range that I have. 172.31.0.0.16 is the range. Now this is not my VPC's range, right? This is my on-premises branch office range where I have my data center. I'm running this there, and my VPC is connected to my data center through a VPN connection or through something else, or this could be another VPC also, right? This is another VPC. I have 2 VPCs. One VPC has got this range. The other VPC has got this range. I want these 2 VPCs to talk to each other because they are all isolated, right? Each VPC does not talk to each other unless you connect it together. So the connecting 2 VPCs, you have to connect through a concept called peering of these 2 VPCs. So you will create a peering connection between these 2 VPCs. So now from this VPC, any traffic originating to the other VPC, which has got the destination as 172.31 range, has to go through that peering connection. That is the target through which it has to pass. Okay, that's why you will specify that ID of the peering connection here. Anything other than that, okay, specifically you have said anything within the VPC, I'm routing it within the VPC. Anything specific to the other VPC B, which has the IP address range of 172.31, it has to go to the peering. Anything other than that, 0000 means anything other than that has to go to internet gateway. So that my EC2 instances will be able to talk to internet. First, as I said, first it will evaluate all the more specific routes first. Whichever is the more specific route, it will take the target of that, and then it will try to route it through that target. If it doesn't find a more specific route, then it will fall back on a generic route like this, specific to an environment, which can be within the VPC or other VPC. If it doesn't find even there, like for example, Google, right? What is Google's IP address today? I mean, it keeps changing, right? I mean, if I say ns lookup google.com, I'm getting 142, 250, 76, 78. If any of you can do it and tell me what is the IP address you are getting, just do ns lookup google.com. Can somebody try it and tell me?
It's 216.58.203.14.
Yes, see, your IP address is changing, correct? Because Google has got multiple servers where it resolves the endpoints, right? It's not always going to one IP address. So that way, if I try google.com from my system, it is basically a 0000 traffic for me, right? Because I don't have a specific route for 142, 250, 76, 78, or I can't have a specific route for internet because it will keep changing. I will only go with the friendly name of google.com. I'm not going to use the IP address every time, correct? So now from that perspective, anything which has 000, which is not specific, which can be anything, it goes to IGW, or it goes to a specific target which can take it to the internet. Okay, so yeah, you have a main route table which says that this is the main route table. You can never delete the main route table. Main route table will always be there, because that's what determines the routing for your VPC and resources within the VPC. You'll never be able to delete the main route table. That gets default created when you create the VPC. And whenever you don't, and you can also create custom route tables, as I said, and you can associate subnets to the custom route table. And then whenever you explicitly associate a subnet to a custom route table, it will get detached from the main route table and it will get attached to the custom route table. I'll explain all of that. Okay, but for now, you guys have to understand it very clearly. What is a route table? How route table works? How do you specify routes in the route table? What are the two key things? One is destination, the other one is target. And how do you route the traffic within the VPC using the local default route which is present in the VPC, so that the traffic does not go outside, traffic stays within the VPC itself. Okay, so these are the things that you all have to understand. So now let's get to the lab session. I'm in my VPC console. I'm in my AWS console. Okay, I'm going to VPC. I'm hitting VPC. So yesterday, what did we create? We created a VPC, correct? Yeah, so this is the default VPC. If I want, I can just rename it as default. Okay, and this is the new VPC that we created. My VPC is the new VPC that we created, which has the range of 10.0.0.0/16, and then we created subnets for that new VPC. We created two subnets for the VPC, subnet 1 and subnet 2, in two different availability zones, which has got 10.0.10/24, which has got 251 IP addresses, 10.0.2/2.0/24. Okay, so now, okay, so how many of you were able to complete till this point? Okay, I'm not asking about the students who still don't have the AWS accounts. I mean, you'll be able to hopefully complete it today. Don't worry about it. Okay, keep your hands raised until I get a sense of it. Don't lower your hands. Please keep your hands raised. Okay, still there are so many people who are yet to complete this. Okay, I can see half of the class has completed it. Okay, okay. Rest of you, don't worry. You'll be able to complete it. Those who don't have accounts, you will be able to close it today. Don't worry about that. Okay, so now we created a VPC yesterday and we created subnets. I'm going back to my good old diagram. Yeah, so this is my diagram. I'm going to come down to paste it here. Okay, this is what you have created, correct? Okay, perfect. Okay, so now this is my VPC. I have two subnets, subnet 1, subnet 2. But now I have to configure the routing for this, right? So how you configure routing? You have to put a route table. You have to create a route table. Route table will have rules, several rules in it, right? I will say First rule number 1. I'll make this big. I'll say first rule number 1. What is rule 1? Rule 1 is, in rule 1, you have two things, right? What is the first one? You have destination. Let's put a table here. And this is my route table. Okay. This is rule number. This is destination target. This is how you define a route table, correct? I mean, that's what we saw the documentation right now, right? Okay, so now first rule, destination is, okay, so now this is my VPC. What is my VPC CIDR range? 10.0.0.0/16. So I want, so within the red box that you see, right? That is the red box is my VPC. Within that, I have different subnets. Don't worry about subnets. But within my VPC, I want any traffic originating for within the VPC itself, like inter-office communication, inter-office telecom system, right? Or intercom system, where destination has got the IP address specific to 10.0.0.0/16, which means anything, any destination which has the IP address as one of those 65,536 IP addresses. Because what is /16? 65,536 IP addresses, correct? Go to CIDR.xyz 10.0.0.0/16. It gives me 65,536 IP addresses. Anything within this range, which is the destination, then my target would be local. So when you say local, it means that within the VPC itself, it won't go outside of VPC. The communication will stay within the VPC. And if I want to talk from from 10.0.1.1 to 10.0.2.50, okay, since the destination is 10.0.2.50 and that 10.0.2.50 basically falls within this range, correct? Within the 65,536 range of whatever my VPC CIDR range is. So it will simply route the traffic locally, and then it will check which subnet has got that, and it will send it to that subnet, and then the router will send it to that particular EC2 instance. Okay, which means it is all local. And I have the second route table, second rule in the route table, which says anything other than that 0.0.0.0/0, anything other than that, where do you want to route? Let us hold on there. Where do we want to route? I'll come there. I'll tell you where to route it. But anything other than that, we have to route it somewhere. You have to route it somewhere. Where do you route? Is a question mark. I'll come to that. For now, don't worry about it. But anything which has the destination as within this 65,536, it will be routed locally. So now let's go back to our console. Now in console on the left side, you have something called route table. Click that route table. And anyways, you have selected the VPC here, filtered all the route tables only for the VPC. So now this is the route table. This is the default route table which gets created when you create the VPC, correct? So now what this route table has, it has got a route table ID, which is a unique ID. Okay. And then it has got explicit subnet associations, edge associations, forget about edge. Then whether it is main route table or a custom route table. When it is yes, it means that it is a main route table. When it is no, it means that it is a custom route table. And then it will also tell which VPC it belongs to. This route table belongs to the VPC ID. And who is the owner? Owner is the account number. Okay, so now let's come down. Summary pretty much has that. Then you go to routes. Okay, so what you have here is the routes. You have four things in the routes. Okay, you have multiple routes. This is nothing but each row in the route table, right? Rule that you define in the route table. The first is destination. What did we give? This is the destination 10.0.0/16. Target is local. Status is active, which means that it is active, right? I mean, it is working. It's in a working condition. This route is in a working condition. Propagated yes or no, you don't have to worry about it. I'll come to that later. Okay, and you can filter by IPv4 routes or IPv6 routes. You can put all routes. Okay, so now, which means that any traffic that is originated for this destination will be routed to this local target. Okay, so it shall be routed to this local target. So now let's go to subnet associations. So now in this case, there are two subnets that are there, right? So this has got two sections to it, right? So now if you see this table on the top, it says you do not have any subnet associations. But if you see, by default, when you create a VPC and when you create subnets, there are routes that the subnet should have, right? Because otherwise, how will it know where to send the traffic to? So the default route for that subnet will be associated with this route table. Okay, by default. Okay, so that through the form of associations. So in this case, the subnets are associated with this route table by default. Whatever you see here, the following subnets have not been explicitly associated with any route tables and are therefore associated with the main route table. So it means that these are associated with the main route table itself. That way, when you create a new subnet, you will see that new subnet will come here. Let's do that. Let's create. Right now, you're seeing that there are only two subnets associated with this, which is the subnets that we created yesterday. Let's create a new subnet. Subnet 3. This is the VPC. Availability zone, I'll put it in the third availability zone. And then I'll say 10.0.3.0/24. And I'll say create. Yeah, it has created a new subnet. This is the subnet ID BAB2BAB. So now if I go to my route table, you will see that routes have not changed, but you would have seen that there is one new subnet which is associated here, which is the third subnet. If you see, this is the third subnet which got associated with the with this route table, the BAB 10.0.3.0/24, because by default the communication within the VPC will stay within the VPC. So by default it is associated with the main route table. Okay, so that's the difference. And when you create a custom route table, you will see that you can actually edit the subnet associations. You can detach a specific subnet from the main route table and you can associate it to the custom route table. You will understand why you want to do that. There are some reasons why you want to do that. I'll come to that in our subsequent sessions. But for now, you understand that when you create a subnet, those subnets are associated with the main route table and not to the custom route table. Okay, you have to explicitly associate it to a custom route table, then it will go away from the main route table. Then you are saying that it's like this, no? So where I have traffic coming from JNQ to Secunderabad, you follow this route table. Instead, you are saying follow this route table. So you will detach it from here and you will attach it to here. So that every time JNTU traffic has to go, it will go through Amirpet and Begumpet and it will reach Secunderabad. That's the difference. Okay. And then edge associations, just leave it for now. Which route propagation also forget it, because we will cover this when we come to VPN. Okay, when we connect VPN connections and things like that, I will cover the route propagations there. Okay, or it is not very important for you guys at this point in time. What is important right now is the summary page, which says what is the route table ID, who's the owner, whether it is the main route table or not, and which VPC it is associated to, and what are the routes that are there for the route table. And you can edit these routes, and you can add a route saying if it is for 0. 0.0.0. Then the target can be any of these. I mean, if you put a firewall, right, and you want to have any outbound traffic, right, by anything that goes to internet, you want to basically pass it through a firewall. Okay, so what you will do in that case is you will install a firewall on an EC2 instance, and then you will use that instance ID to route the traffic through. Okay, or you can, there are multiple other things, right? So where such as you can send it to a peering connection. Peering connection is a VPC peering connection. Don't worry about all of that. So these are the options that you get. Now in this case, I don't have an internet gateway associated with my VPC, so I'll just leave it blank for now. I can't route my 000 traffic to anywhere because I don't have any provision to route my 00 traffic to anywhere. So I'll not do it. I'll just click this and I'll say cancel. I won't be able to do anything there. Okay, so now let me go back. Okay, so within the VPC, I'm able to route the traffic through this local rule that I have created in the route table. So now if I were to route it to internet 0000, then what would I need? I need an internet gateway. Okay, so that is where you need to attach an internet gateway to your VPC. IGW, it's called internet gateway. What internet gateway does is it basically takes your traffic to internet. It takes to internet. It takes it to the internet. Okay, so then once you have the internet gateway created, then you can say that any traffic other than my local VPC, anything other than that, I have to basically route it to internet gateway, which is the internet gateway. So if it will first try to resolve it within the more specific route. If it doesn't resolve, then it will take it to this default route, which will take it to internet gateway, and then internet gateway will resolve it on the internet and it will send it to that particular IP address. Okay, so now let us see how to create an internet gateway. There's something called internet gateways here. Click on internet gateways. So what is internet gateway, by the way? Okay, an internet gateway is a scalable resource which allows access to internet. It's like your modem. It's like your home modem, right? Internet gateway is like your home modem. Yeah. Okay, an internet gateway is a horizontally scaled, redundant, and highly available VPC component that allows communication between your VPC and the internet, because you want your EC2 instances to talk to internet, right? Otherwise, how will it download updates? How can it talk to like external systems like Google or any other things, or you want to have an API based integration? It has to go over internet, correct? An internet gateway serves two purposes: to provide a target in your VPC route table for internet routable traffic. That's what we precisely did just now. And to perform network address translations for instances that have been assigned public IPv4 addresses. I'll come to this a bit later. Internet gateway supports both IPv4 and IPv6 traffic. So basically, there is no limit for the internet gateway. It can. There's no limit for the bandwidth that the internet gateway can give. Like for your home internet, you have a limit, no, like 40 Mbps, 100 Mbps, and 60 Mbps, and things like that. Whereas for internet gateway, there is no limit for the internet gateway at all, right? It can scale as much as you want it to scale. Okay, to enable access to or from the internet, you must do the following: attach an internet gateway to your VPC, add a route to your subnet route table that directs internet bound traffic to the internet gateway. Okay, so that's what we are going to do now. How you do it? If you see in your subnet route table that you specify a route for the internet gateway to all destinations not explicitly known to the route table. 0000 means they are not explicitly known to the route table. Implicitly they are known, but they're not explicitly known. You're not specifying. Okay, you're only saying that anything other than this, which is 0000, please go outside. Like this, no? Like you go for an event, you'll have two kinds of queues, right? So one queue will have members, whoever has got membership to that event. Okay, whoever has got an annual membership, go here, go specifically where you can follow the where you can quickly go find your places and you can set, and you will get more premium seats in the front. Those who don't have membership go through the general route. That is the difference. So here, those who don't have any specific explicit known routes will actually go through this 0000. Okay, so I'm going here. So now, see, I have a internet gateway associated to my default VPC, right? I don't want to use this, right? So I will create a new internet gateway because internet gateway is a VPC specific resource. Let me filter it by VPC only here. If I filter my VPC, which VPC is selected? Yeah. So if you see, if I filter my VPC, I have no internet gateways associated to my VPC because internet gateway is a VPC specific resource. You can't reuse a internet gateway for one VPC with another VPC. Okay. So now I'll go create an internet gateway for my VPC, which ends with 1616D. So it's very simple. Just go click on internet gateway and you say you should just give some name to it. My IGW or my VPC IGW. And then say create internet gateway. That's it. It's done. You have created an internet gateway for your VPC. Okay. So I've created a new internet gateway. You've created a new internet gateway called my VPC IGW, but you have to attach it. Right now it is detached. It is not attached to any VPC. Okay. So now how you attach it to VPCs, you go click on actions and you say, you have multiple options here. You can delete this also, but you can attach it to a VPC. In this case, the VPC that I want to be attached to is my VPC because the other internet gateway is attached to the other VPC. I'll just say attach internet gateway. You will see that this is attached to this VPC. This internet gateway is attached to this VPC. Okay, so now I'll go back to my route tables. So now what I've done is I have created this, I've attached it to my VPC. Okay, but I'm yet to do the route part. This part I'm yet to do because any traffic originating from my VPC for any destination which is not explicitly mentioned, it has to go to 000, right? Destination is 000, correct? And it has to go through internet gateway, which is my router, which is my external router, my modem or router, that whatever you call it, right? That is called internet gateway. So now let me go add a route which says 0.0.0.0, which is not explicit, right? I mean, here, this is an explicit route, which has 10.0.0.0/16, which is at 65,536 IP addresses. Anything other than that 65,536. Now my members who have bought annual subscriptions are 65,536 members who have bought annual subscription. All of you go within the VPC itself. Anybody, any other guest who don't have annual subscription, it can be anybody, any public, general public who gets in has to go through the internet gateway. So here you select an internet gateway and you will get this internet gateway that you just provisioned called my VPC IGW. Select that and say save routes. Yeah, so it has saved that route, and you know that anything which is within the range of 65,536 IP addresses goes to this local. Anything other than that goes through this internet gateway. Okay, so I'm going to take a pause here, okay, because this is too much of information today. I want all of you guys to assimilate it, absorb it, understand the concepts very well. I'm going to take a pause here and I'm going to give you some exercises for today. Exercises for today is go through these two links, whatever I just explained you. And assignment is you would have created the VPC yesterday. If not, first complete yesterday's exercise, then come to today's. What is yesterday's exercise? Create a new VPC, create two subnets, learn the concepts of IP addressing, follow the below architecture. Okay. So now in today's, I'm going to delete this. In today's assignment, I want you all to, after you created this, I want all of you to open the default main route table for the VPC you had created yesterday. Review the local route. I'll say local route. Let me review the local route with destination as 10.0.0.0/16. Okay, and understand what a local route means. Okay, for that you have to read this. You have to read these two links. Okay. Then fourth, create an internet gateway called myVPC IGW. Attach the internet gateway, attach the myVPC IGW to the myVPC. This is myVPC, right? That's the naming convention we gave yesterday. To the myVPC. Open the main route table. Go to routes. Add a new route. Edit the routes. First, edit the routes by clicking edit routes button. Then add a route which says destination is 0.0.0.0/0. Target is from the drop down, select internet gateway and then select the newly created myVPC IGW. Okay, are we all clear? Do this exercise today. I'm going to put this here, the diagram for today. Okay, so do this exercise today. I'll also give you this PPT so that you can just go through some of this whiteboarding sessions so that you will feel more connected to whatever I explained. Let's do this today. More importantly, read these two. Very, very important. These two links, VPC route tables and internet gateway. Apart from whatever I had asked you to read yesterday, read this today and go through some videos on route tables, on internet gateways and things like that, VPCs. There are tons of videos available in YouTube. You can go through that. Okay, and then complete this assignment. And then we'll again meet tomorrow to see how actually the routes are working. Okay, we'll provision a few EC2 instances and I'll show you how the EC2 instance is able to talk to another EC2 instance, how EC2 instance is able to talk to a public internet, how it is able to browse google.com, right? And also I'll explain you what a public subnet and private subnet means. These are the topics for tomorrow. Okay.
Hello.
Yeah.
Sir, good morning.
Good morning.
I wanted to know about any certification would be beneficial for freshers, and what would be the starting certification if we ought to do any
Okay,
certification.
okay, good question. I'll explain you. If you go to AWS certifications, AWS certifications. If you have, these are the certifications that are available. Okay. So now you're at the foundational layer, correct? So there are 4 layers, right? Foundational, associate, professional, and specialty. Professional is like professional, who has at least 2 years of experience. Okay. Since you're all freshers, don't look at it. Associate is for somebody who has 1 year of experience. Okay. So now you will eventually do that. Maybe once you get into jobs and once you start working with this, you will eventually do that. But for now, what you guys can do is you can look at the cloud practitioner certification, which also has a minimum thing that 6 months of fundamental AWS cloud and industry knowledge. Okay. But nevertheless, you can always do this cloud practitioner even now, because what I would suggest is you wait for this course to get completed. Okay. Our RPL course to get completed, where I will cover most of the foundational and associate in this course. In fact, we are doing much more than foundational. We are actually at the associate level. Whatever I'm teaching you right now, it's at this level, solutions architect level, or sysops administrator level, which is the associate level. Okay, because what you learn in the foundational is basically very, very rudimentary. That is for probably non-technical, maybe somebody who's a manager or somebody who's a project manager or a sales kind of a person, marketing kind of people would actually do cloud practitioner. But nevertheless, that will also give you a good exposure, and having one certification is good. But I would suggest you guys have to aspire for associate solutions architect. Okay, that gives you, or sysops administrator. I would say, in fact, don't even go for solutions architect right now, because that would need some experience. You might struggle right now. Go for sysops administrator at a later point in time. Maybe after 2 months, you can start preparing for the sysops administrator. I'll point you to all the material and everything that is there, which can help you do well on a sysops administrator. Okay, associate, which will give you very good exposure to how to build AWS cloud, how to operate on AWS cloud, and things like that.
And
Okay.
what is the difference between AWS developer and solution architect?
Okay, so solutions architect is a broad level role where, as an architect, one a person is expected to understand and architect systems on AWS, on the AWS platform. Whereas a developer is more specific to developing applications, right, and building solutions on AWS, building applications or building solutions, developing applications on AWS. Okay, that is for developers. This is for architects. As an architect, you have a more broader view, and you'll be able to build architect systems. You'll be able to give a solutions architecture, which says that this is how the solution would look like. These are the various components of the solutions architecture. Whereas developer is the one who implements those solutions and who builds code and who writes code. Okay. Okay. All right. So what I'm going
Thank
to do
you.
is I'm going to send this. Sure. No problem. I'm going to
Thank
send
you.
you this in the chat. I'm going to paste it in the chat. So all of you can see. Actually, it's getting interesting, right? Day by day, right? Because you're actually doing something hands-on, and some of these VPC is all very fundamental to learn. And trust me, you're actually getting 1 or 2 steps ahead of your other peers by understanding all of these concepts. And when you actually attend interviews, you will be able to answer some of these very clear and crisp, right? Like what is a CIDR notation, right? What is an IP address CIDR notation? I'm sure all of you will be able to answer it. What does 0000/0 mean? what is /16, what is /24 mean. Okay, all of this are quite interesting, and you'll be able to appreciate these concepts as you get into jobs, and as you actually start implementing this, you'll be able to understand this much better. Okay, I'll also give you the PPT.
Sir?
Yeah.
Sir, I have one doubt here. To provide security within the organization, are we going for VPCs? Because AWS itself is providing very good security through the private cloud, then why we are going for VPCs?
No, so okay, so it's basically, as I said, no. So VPC is a logical construct, right? So again, VPC is virtual private cloud. It is a part of the public cloud, but it is a virtual private cloud. So
Okay,
now,
sir.
when you want to logically extend your on-premise data center, you can go for VPCs, or you want to build something new. You don't have a on-premise data center at all. You want to build something new. You can start with AWS, and the first step in AWS is you have to create your own VPC, where all your you want to construct a house. What will you do first? You will first go procure land, correct? You'll buy a land,
Yes, sir.
and then you will build a compound wall around the land, fencing around the land, correct? So now think of a VPC as a compound wall around your land. And then within the land, whatever 250, 300 square yards, then you will start constructing the house. You will start with a foundation, and then you'll raise floors and things like that, right? Now VPC is like the land that you bought. Okay, and
Okay,
you have
sir.
built a compound wall around the land, and security is something will come later. Okay, right now I have not touched upon security. Security will come later, but for now, just understand it as a logical segregation of a space within AWS is the VPC, and your VPC belongs to you only. It does not belong to others.